Warshall's algorithm to find transitive closure. First of all, we need to know the meaning of these words. What is a directed graph? A graph whose every edge is directed is called directed graph or digraph. Adjacency matrix. The adjacency matrix A is equal to A of ij of a directed graph is the Boolean matrix that has 1 if there is a directed edge from ith vertex to the jth vertex, 0 otherwise. Transitive closure of a directed graph with n vertices can be defined as the n by n matrix T is equal to Tij, in which elements in the ith row and the jth column is 1 if there exists a non-trivial directed path, that is, a directed path with a positive length from ith vertex to the jth vertex, otherwise it is 0. The transitive closure provides reachability information about a digraph. Warshall's algorithm is used to find out the transitive closure. On the kth iteration, it determines if a path exists between two vertices I and j using the vertices among 1 to k as intermediates. On the kth iteration, it determines if a path exists between I and j using the vertices from 1 to k as intermediates. There are two cases. In the first case, there exists a path from I to j. In the second case, we use an intermediate vertex and then find the path. Here, k is the intermediate vertex. We make use of logical and logical OR here. When we combine case 1 and case 2, the final equation will be Rk of I comma j is equal to Rk minus 1 of I comma j or Rk minus 1 of I comma k and Rk minus 1 of k comma j. This is the Warshall's algorithm formula that we need to remember while solving problems. Let's consider an example. We have to find the transitive closure for the given digraph using Warshall's algorithm. Initially, we find out R of 0, which is the adjacency matrix of this digraph. We put 1 if there exists a path between two vertices. For example, there is a path between B to A. So we put 1 here. And there exists a path from B to D. So 1 here. And A to C. And then D to B. We consider each node as intermediate node to generate new paths. In the first round, k is equal to 1. Vertex 1 can be intermediate node. Keep this formula in mind. We apply this formula over here. Now k is 1. We can find out R1 of 2, 3 as R0 of 2, 3 or R0 of 2, 1 and R0 of 1, 3. We can either find out if there is a direct path from 2 to 3 or we can make vertex 1 as the intermediate vertex and then find out the path. So R0 of 2, 3 is 0 or R0 of 2, 1 is 1 and R0 of 1, 3 is 1. It is 0 or 1 and 1 is 1. 0 or 1 is 1. Making use of vertex 1 as an intermediate vertex, we found out a path between 2 and 3. Now R of 1 looks something like this. For the next round, k is equal to 2. Vertex 1, 2 can be intermediate nodes. R2 of 4 comma 1 is equal to R1 of 4 comma 1 or R1 of 4 comma 2 and R1 of 2 comma 1. We can see that R1 of 4 comma 1 is 0 or R1 of 4 comma 2 is 1 and R1 of 2 comma 1 is 1. 0 or 1 and 1 is 1. 0 or 1 is 1. In the new matrix R2, we can make 4 comma 1 as 1. Next, we can find out R2 of 4 comma 3 as R1 of 4 comma 3 or R1 of 4 comma 2 and R1 of 2 comma 3. R1 of 4 comma 3. 4 comma 3 is 0 or R1 of 4 comma 2 is 1 and R1 of 2 comma 3 is also 1. 0 or 1 and 1 is 1. 0 or 1 is 1. In the matrix R2, we can make 4 comma 3 as 1. We can find one more path R2 of 4 comma 4, that is R1 of 4 comma 4 or R1 of 4 comma 2 and R1 of 2 comma 4. R1 of 4 comma 4 is 0 or R1 of 4 comma 2 is 1 and R1 of 2 comma 4 is 1. 0 or 1 and 1 is 1. 0 or 1, 1. In R2, 4 comma 4 will be 1. So with vertex 2 as an intermediate vertex, we found out the new paths. The new matrix R2 looks like this. We got these three new paths. Next, k is equal to 3. Vertex 1, 2, 3 can be intermediate nodes. In this round, there is no change as we can't find out any new path. Therefore, R3 is same as R2. Next, k becomes 4. Vertex 1, 2, 3, 4 can be intermediate nodes. We can find out R4 of 2, 2. It will be R3 of 2, 2 or R3 of 2, 4 and R3 of 4, 2. R3 of 2, 2 is 0 or R3 of 2, 4 is 1 and R3 of 4, 2 is 1. 0 or 1 and 1 is 1. 0 or 1, 1. In R4, we can make 2, 2 as 1. So finally, R4 is the transitive closure for the given graph. I made changes to the same matrix. When you are practicing, you can write the matrices R1, R2, R3, R4 separately and then understand. To summarize, we used different nodes as intermediate nodes and found out new paths between the two nodes. When we made vertex 1 as intermediate, we found out this new path from B to C. Then when we made vertex 2 as intermediate, we found out 3 new paths. Then vertex 3, nothing. Vertex 4, we found out this new path from B to B.